Hi everybody, I'm going to talk today about limits, which was chapter 2, and indeterminate forms, which we talked about in chapter 2, and then something new, L'Hopital's rule. So we want to take good notes here, especially when we get this rule going and start talking about indeterminate forms. Indeterminate means you cannot determine the limit with direct substitution. And the ones that we used when we were in chapter 2 or when we use direct substitution to evaluate a limit, if we got 0 over 0, or any kind of positive or negative infinity over a positive or negative infinity, right? Those are the indeterminate forms. And we said, hey, when I get those, I have to find another way. And then I want to make sure that we understand what is not indeterminate. If you have a limit and you apply it and you get infinity plus infinity, that's actually infinite. We would say that the limit does not exist there. If you get a negative infinity minus an infinity, we would also say that the limit does not exist there. Your book may write negative infinity. And if we have 0 divided by infinity, we actually get 0. And if we have infinity divided by 0, we will also get an infinity, which means that the limit does not exist. So these are not indeterminate. Don't mistake those for these indeterminate forms that we're going to talk about. So let's review these indeterminate forms. Let's try one from chapter 2. When we use direct substitution here, we end up with 0 divided by 0, and that's indeterminate. So we're not going to make guesses. What we're going to do is find another way. And the way that we found to do that was to factor and reduce. And when we factor and reduce, we get x plus 3, and then we can try to apply the limit again. And this time it's not indeterminate when we use direct substitution. The limit is actually 6. And that's a technique we had from chapter 2. If we find the limit as we approach infinity here and we try to use direct substitution, we would get an infinity over infinity, which is indeterminate. It's one of the ones that we used in chapter 2. And we said the better way to do this one is remember that a limit as we approach infinity is actually looking for a horizontal asymptote. And we went back to the old algebra 2 way. Oh, the highest powers are the same. We'll make a fraction out of the coefficients. 3 over 6, we would get 1/2 is the limit. If you doubt any of these, get in your calculator and look, right? The limit is what the y value of this function looks like it's going to at this x value. Okay, then this one also would be a horizontal asymptote type problem. If you use direct substitution, you would get infinity over infinity, but we can use that method you had from algebra 2. The power in the bottom is bigger than the power in the top, so this limit would go to 0. Now, if we plug in a 0 here, the sign at 0 is 0, and x is 0. We get an indeterminate form, and this one is not factorable. We don't have any other tricks for this, so what we did was we got in our calculator. And you should pause me, get in your calculator, and remind yourself that this was an identity we talked about. That graph, if you look right around 0, this graph looks like it has a y value of 1, and that is the limit there. And then this one, if we plug in the 0, we get e to the 0, which is 1 minus 1 is 0, over 0. And once again, we have an indeterminate form, and we can't, well, we can factor this, but we can't factor and reduce. We don't have a way to do this problem yet, so we would get in our calculator. And you could see in your calculator, and I suggest you do that your limit would be 2. So we had to use our calculator for these. After we learn the L'Hopital's rule, we won't have to use our calculator anymore. So let's try. Let me introduce you to L'Hopital's rule, and then we will try those two examples again and show how algebraically using L'Hopital's rule that you can find these limits. Okay, so this is the rule. If you have an indeterminate form of 0 over 0, then this is true. The limit of this quotient would be the same as the limit of the quotient made from the derivatives. Now, this is not the quotient rule. I didn't low, d high, d low, anything, right? All I did was take the derivative of the top, the numerator, and the derivative of the bottom, the denominator, and I could reapply the limit. Okay, just like we did when we factored and reduced and tried direct substitution again. We'll just take a derivative, try direct substitution again. This also applies to the other indeterminate forms that are written in fraction form. And that's key, that you can only use L'Hopital's rule when the indeterminate forms are in fraction form. And that means our good old 0 over 0 and our any kind of infinity over any kind of infinity. These are the only times that you can use L'Hopital's rule. Okay, so let's try it. This one we already said, if we plug in, we know the answer is 1, but if we do direct substitution, and you need to verify that it is an indeterminate form before you use L'Hopital's rule. You have to show that. So we see it's indeterminate, and we don't have any other factoring. It's not a limit infinity, so it's not a horizontal asymptote. So we're just going to go ahead and take the derivative of the top, which is derivative of sine is cosine, over the derivative of the denominator, which is 1, and we're just going to try direct substitution again. Okay, and I usually put a little LH here when I've used L'Hopital, just so you guys can follow in my notes and on the homework answers. So let's plug in again. Cosine at 0 is 1, divided by 1 is 1, and that's exactly what we got when we used our calculator. Let's try L'Hopital's rule on the other one that we had to use our calculator on. I believe we got that limit was 2 in our calculator. So let's try it. If we plug in a 0, we do get the indeterminate form 0 over 0. You need to say that. And so I'm going to go ahead and try L'Hopital's rule because there isn't another easier way. I know that I can't factor and reduce, and it's not a horizontal asymptote, a limit at infinity. So we're just going to use this L'Hopital's rule. And then we'll use direct substitution again. Derivative of e to the 2x is itself times the derivative of the inner function. And then derivative of -1 is 0 over derivative of x is 1. And now that we've used L'Hopital's rule, derivative of the top over derivative of the bottom, supposedly we can try direct substitution again. And if we plug in a 0 here, we get e to the 2 times 0. E to the 0 is 1, so 2 times 1 is 2, divided by 1 is 2. And that's exactly what we got when we used our calculator. So that's L'Hopital's rule. Make sure you have it written down and that you know that it needs to be in one of those fraction form indeterminants before you can use it. Thanks, folks.